So I've been talking on and off about continuity. I've been mentioning a function is continuous under certain conditions, and we're going to just really sit down and formalize that concept now. So this is our topics. Continuity is going to be section 2.3 in your book, and then instantaneous rate of change, which is 2.4 in your book, but we're not going to use the book for that because we already did instantaneous rate of change. We are going to use the book for continuity, 2.3. All right, so here's the definition. So this is the main thing you want to know about continuity. We say a function f is continuous at the point x equals c if and only if these three things have to all be true. All right, so this is an and. F of c exists, the limit as x approaches c of f of x exists, and the limit as x approaches c of f of x equals f of c. And these are the ideas that you are going to use to justify that function is continuous. So here's our first two questions. I have a graph and I'm asking if f of x is continuous at c, justify your answer, and another graph and I'm asking the same questions. F of x continuous at c, justify your answer. You should take a moment to see what you can come up with on that, and then I'll share my answers as soon as you come back. So I'm now assuming you have left, you've made an answer to this question, and you are back. So, well, if you're not back, you can't hear me, I guess. Is f of x continuous at c or not? No. All right, no. This is the key thing. When we justify a continuity statement, there are very specific ways that you need to do that. You need to refer to the 3 points of the definition, and you need to state which one of these three things fails. Which one of these three things fails in this case? The first one fails. So no, because f of c does not exist. All right, and as long as we fail any one of those criteria, then the function is not continuous. In order for it to be continuous, they need to all be true, and I need to say that they're all true. All right, number two, is f of x continuous at c in this case? Well, there's no hole or jump, so I expect it to be continuous, but I need to justify it. So I'm going to say yes, but how am I going to justify this? I need to say that f of c exists. So f of c exists. The limit as x approaches c of f of x exists, right? Because the limit from the left and the limit from the right are the same. I don't have to justify that, by the way, unless they ask me to justify that the limit exists. If they ask me to justify the function is continuous, I get to look at the graph and say I can see that the limit exists, okay? And the limit as x approaches c of f of x equals y1, which happens to equal f of c. So if this was a number like 4, we would say it equals 4. All right, so that's justifying that something is continuous. When you're going to say the function is continuous, you need to say three things. When you say the function is not continuous, you only need to say one thing. All right, next. What do you think about these two? Have a look at these two questions, pause the video, and come back with your answers. Okay, here you are back with your answers. Is f of x continuous at c? I hope you said no. All right. Justify your answer. So we only have to say one of the three things is wrong. Which one of the three things is wrong? Well, what's the limit as x approaches c of f of x? It's y1. But what's f of c? It's y2, and they're not equal. So the reason is limit as x approaches c of f of x equals y1, which is not equal to f of c, which is y2. So the key things I need to get in there is that the limit as x approaches c does not equal the function value. And then I've correctly justified this answer. All right, number 4. Is this function continuous? What did you say? Well, I hope you said no. And what's the reason this time? Of these three things that we have, which one of these three things is not true? Well, the limit doesn't exist at c. All right, and again, we don't have to justify that if we're justifying a continuity statement. No, because the limit as x approaches c of f of x does not exist. All right, so that's how you justify continuity statements. Now I've posted on Google Classroom and also on the handouts page of the website this fine document that says justifying claims for limits and continuity. And it has all the things that you need to say to justify a claim, for example, that limit as x approaches c exists. And this is going to be on the assessment that we do. So if I want to justify that a certain limit exists, and usually for this assessment, by the way, I'm going to tell you that the limit exists and what it is, and I'm going to say, you just justify this. So here's what you need to say about it. All three of the things must be true. Limit as x approaches c from the right exists, limit as x approaches c from the left exists, and the two limits are equal to each other. So we've done that sort of a little bit. So, like, let's say you had a graph that looks like this, and this is 2 and this is 4, and I said justify that the limit as x approaches 2 of f of x is 4, you would say limit as x approaches 2 from the left of f of x equals 4, limit as x approaches 2 from the right of f of x equals 4, so the limit as x approaches 2 from the left of f of x equals the limit as x approaches 2 from the right of f of x. So that's what you would need to do, just justify that that limit is 4. All right, you could write this all in one sentence in a way. All right, so next, if I want to justify that the limit does not exist, I only need to do one thing. So this is a typical thing. There are 3 criteria for each thing. If I want to say that something is true, I need to show that all 3 things are true. If I want to say that something's not true, I only need to fail one of them. Right? So either the limit as x approaches c from the right does not exist, or the limit as x approaches c from the left does not exist, or the limit as x approaches c from the right does not equal limit as x approaches c from the left. Now, these left-handed limits generally are going to exist. You can come up with a function, I'll say I can come up with a function where the limit as x approaches c from the left or right doesn't exist, but they're pretty weird. All right? So let's say you had a function like this, and let's say this is 3, and this is 5, and this is 2, and the question says, prove that the limit as x approaches 2 does not exist. You would say limit as x approaches 2 of f of x does not exist because, and you want to specify numbers. So limit as x approaches 2 from the left of f of x is 3. Limit as x approaches 2 from the right of f of x is 5. And you could do like this. 3 does not equal 5. Right? There are lots of different ways you could sort of write it. All right, so that's limits, which you've actually done quite a bit of this already. Now, I want to compare that to function is continuous. How do I justify a function is continuous? We've just done a couple of these, so I won't do additional examples. If I want to claim that f of x is continuous at x equals c, and I want to justify that, then I need to show that all 3 of these things are true. That f of x exists, limit as x approaches c exists, and f of x equals, oh, that should say f of c. Geez, I got to reprint that. F of c equals limit as x approaches c of f of x. All right, and then the function is not continuous at x equals c. This also is c. I just sort of did a reprint on this, and I messed that up. All right, so to justify that f of x is, wow, not continuous. These will be already corrected when you look at your sheet. To justify the claim that f of x is not continuous at x equals c, any one of these 3 must be true, right? So either f of x does not exist, that should be f of c does not exist, or limit as x approaches c of f of x does not exist, or f of x does not equal limit as x approaches c of f of x. And we've seen examples of these 2 things. If you want to go back to the beginning and watch the beginning of this video over, it shows how to apply these things.